Hi, today we will discuss about common dynamic programming question style called number of possible ways. One of the easiest example is called number of possible ways of climbing stairs. So you are given a stairs of n steps and you can only climb like one step at a time or two steps at a time. So you can climb one step or two steps at a time, and you're being asked like how to reach n steps of the stairs. So this question is a typical dynamic programming question, which asks you a number of possible ways of achieving certain goal with a certain ability you have or certain constraint you have. So in this example here, we need first the way of thinking in dynamic programming is you need to know what is the base case here. So if let's say n is equals to 0, like how many ways to climb the stairs with a step of 0. So here you have step of zeros, and actually there is one way to achieve it, which is stay still. So you don't climb at all and you are already at the step 0 there. So when n is equals 1, the output is equals 1. And you think how many ways to achieve n equals 1. So n equals 1 actually is coming from you go up one step right at a time, and if you go two steps you will not end up in the position n equals 1. So only one way to achieve it, which is doing climbing by one step. So the output is still 1. Right, and when it comes to n is equals to 2, here you can see other than we climb two steps at a time, so from 0 climbing to step 2, also we can do is from step 1 climb directly to step 2. So in this case there is actually two ways to achieve it, the numbers of way we can climb to step 1 and the numbers of way we can climb to step 0. Basically these two, when you combine it together, it will become the number of ways we can climb to n equals 2. So the output here is actually 2. Okay, and same thing here when we want to climb to this step here. Actually the number of way we can climb to step 2, basically here we have two ways to do it, right? And we have one way to do it here. So by this one way, right, so this one way actually when it climb another one step, it's actually ending up here as a two numbers of way is climbing two step or from 0, or climbing one step from 1, or directly from step of step 1 we directly go two step ahead, right? So this one way plus this two way will be equals to n equals 3, which is 1 plus 2 is equals 3 here. So this way of building the logic is called bottom-up approach. So when we say n equals 3, we can say output is when fn minus 1 plus f of n minus 2. Okay, so when n is equals 3, it will be f of 2, which is 2 plus 1. So it will be equals 3 there. So yeah, one other approach to think of this way is we can think it from the goal itself, and from the goal we try to achieve what is the base case there. We try to split from our actual goal to what we can do as a smaller problem, and we keep dividing the problem until we find the base case. So both case we will need to realize n equals 0 is our base case there, which is saying when the n is equals 0, the output should be 1. Okay, let's try to take a look. So the general formula is f of n is equals to f of n minus 1 plus f of n minus 2. With the given condition of base case is when f is equals 0, we know it's only one way to form it. When the stair step is 0, it's equals to one way to solve it. And when f is less than 0, for example when we try to climb to 1, there is no stairs of minus 1. So in that case, it's not counted as a way to climb to stair 1 here. So we want to eliminate this possibility. So to eliminate this possibility, when f is smaller, when the n is smaller than 0, we always say the f smaller than 0, the base case will be equals to 0. And when it's come to f0 will equals to 1, and when we goes to f1 actually, so it will be like f of 0 plus f of minus 1. So it will be 1 plus 0, which is 1, and f2 will be like 1 plus 1, which will equals 2, and 3 will be 2 plus 1, which equal 3. And when n is equals to 4, the output will be like 3 plus 2, which is 5, and we can do it so on and so forth. Actually, like this is very similar to what we think of as a Fibonacci series, and we actually can do a dynamic programming out of it, like because when we calculate for the f of n minus 1 and n minus 2, actually n minus 1 in itself, like so we try to do fn, and fn will split into fn minus 1 and f of n minus 2, right? And yeah, as you can see, like here it will split again, like f of n minus 2 and f of n minus 3, and here it will split into f of n minus 3 and f of n minus 4, and so on until it reaches the base case of f equals 0 or f equals less than 0. As you can see here, fn n minus 2 and fn minus 2 here is being recomputed every time. So dynamic programming is like to like when you already calculate fn minus 2 here, when you go here you try to catch it up, so you don't do the recomputation again, and can save some computation time. So let's try to take a look on the code itself. So I will move the code here, and as you can see, like we are trying to climbing stairs as I explained. When n is smaller than 0, which is f smaller than 0 of n, we return a 0 in that case, and when n is equals to 0, we return 1. And here is like our formula. So fn is equals to fn minus 1 plus fn minus 2. And then to do the dynamic programming part is basically we try to create a memoization here, with saying like if we already calculated, like let's say f3, then when f3 is already in the cache, then we directly return the f3 instead of like doing the recursion over this thing. But if it's the first time doing the recursion, then we try to store the result in the DP. So next time when we computed the same problem, then we don't have to do the recursion again, so we can save a lot of time out of it. So one of the follow-up question in the climbing stairs problem is like, so currently we are saying like given n steps, and our ability is like 1 step or 2 step from our current point. And one of the follow-up question, it can become, we want to change our ability to say 1 to k steps. So like instead of 1 or 2 steps, it actually can form like 1 to k step. Like if the ability is like a person can like do 3 steps at a time, then we need to change our code. How does the code looks like in that case? Yeah, so as you can see, we try to put the k into the parameter. So k is like the number of steps, and then basically we will do a very similar dynamic programming. If we already calculated the step of n, then we directly return it. But if it's first time we compute it, then we try to store it into the memoization. But the only changing part is like our formulas. So instead of hardcoding the formulas of n minus 2 plus n minus 1, instead we can like do a for loop here and try to do from n minus 1 until n minus k of the problem itself. So this code is representing a top-down approach, and if you are doing like a bottom-up approach, it's probably gonna be an array. Yeah. So here we try to loop from 1 to k, because k will be a parameter of how many steps we want to do, right? And yeah, this will be like one kind of the follow-up question it might ask. And maybe the other kind of problem that we will be able to do is like, let's say given n steps and we change the ability again. So the ability is not a sequence of steps like 1 to k, but instead it will say you will be able to do 1 step or 3 steps at a time, for example, right? And in this case, then we also need to evaluate like, so how we going to change our code. Like instead of like doing a for loop from 1 to k, we will try to loop from the possible step we will able to take. So I will try to put the code here. Yeah, so almost a similar question, but instead of receiving a k, we receive array of steps. So when step is smaller than 0, we return 0 in that case, because it's an invalid start. And when the n is equals to 0, it return 1. And also you notice like the dynamic programming didn't change for the key. It will still be n, because we calculate the key here will be the n, because all the steps will be put into consideration, and this parameter of steps basically never change. It's a constant parameter. But you can see here the formula will change. Instead of like the first time we do hard coding of n-1 and n-2, second time we do a for loop from 1 to k, and this time we have an array of steps. So we loop through all the steps as a step, and then add up all the possible outcome from it as the number of possible ways of such sub-problem, and like after we solve each of the sub-problem, we add it up to our output and then return the output here. Yeah, and that's it for this question. And maybe one more follow-up is they might ask you like, what if the n is very large? Then this integer here, it might overflow. Like when the n is pretty large, let's assume like we have a big amount of memory, still like this integer might not be able to store all of the output here. It's one of the very common question pattern, which typically they will say when the number is really large to be represented as an integer, so you need to represent the output in your output modulus 10 power 9 plus 7. So this number is basically like a prime number basically, and we try to modulo it from the output since the output is very big. So but they they want to make the output representable in an integer, and they want to check your correctness. Usually like this kind of question is very common in online judge. Yeah, so what you can do instead is like, because it's a plus operator, so actually like integer is actually up to like around 2 billion. So this is like around 1 billion. So every time you already plus some of the sub-problem to the output, what you can add around here is like, you say output modulus 10 power 9 plus 7. So in that case, like we can make sure it never reaches an integer overflow. Or if they want a very big number, probably you should verify like whether they want it's able to fit into long or otherwise big integer. But usually like in online judge kind of thing, they will usually expect you to modulus it by 10 power 9 plus 7, which is a very common pattern in this kind of question. Yeah, so that's it for this question. So hope you like it, and hit like and subscribe if you like it and you want to enjoy more of such content in the future. And thank you for watching.